Antarctica is thought of as a place of endless white silence, frozen, still, lifeless. But beneath that silence, rivers hundreds of kilometers long race through total darkness, connecting lakes sealed off for millions of years and hiding life no sunlight has ever touched. Beneath the white silence is not just a title, it is the reality scientists faced when radar first revealed a moving, unseen world beneath 4 kilometers of ice. If this pulse is real, what else waits to be uncovered below the ice? And how much could its discovery rewrite what we know about Earth itself? 4 kilometers of Antarctic ice once seemed impenetrable, an unbroken expanse where nothing could move unnoticed. Yet in the early 2000s, a new kind of vision began to pierce that white silence. Scientists trained satellites and aircraft-mounted radar on the continent, searching for any sign of change. Their tools were pulses of laser light from NASA's ICESat and sweeping radio waves from Operation Icebridge. What returned was not the expected monotony, but patterns, subtle rises and falls in the surface, traced in precise meter-by-meter detail. Helen Fricker, a glaciologist with a background in radar physics, spent months poring over ICESat data. In 2006, she noticed something strange. The ice surface in certain places would lift by several meters over months, then slowly sink back down. These were not random fluctuations. They stretched for kilometers, repeating in cycles, like a slow heartbeat beneath the white. Fricker realized she was watching water move, lakes filling and draining far below, their motion rippling upward through nearly 4,000 meters of ice. The movement was quiet, invisible, and enormous. The evidence grew with each new mission. ICESat-2, launched in 2018, sharpened the focus, measuring surface elevation every 91 meters along its orbit. Cryosat-2's radar altimetry mapped broad kilometer-scale undulations, confirming that these blisters and dips were not isolated. They formed networks, with water shifting between hidden lakes and channels, sometimes draining the equivalent of an entire city reservoir in a single event. Airborne radar, flying grid lines over the ice, mapped the buried topography, revealing valleys, ridges, and the unmistakable signatures of long, winding rivers. Remote sensing turned the continent into a living map. Over 400 subglacial lakes have now been cataloged, with at least 231 showing signs of activity, periodically swelling and collapsing as water pulses through the system. In just the past 2 years, satellites have revealed 85 new lakes and traced drainage events that span entire basins. The scale is staggering. Some channels stretch for hundreds of kilometers, rivaling the length of the Thames or the Seine, yet remain completely hidden from view. These discoveries are not just numbers on a screen. Each change in elevation, each mapped channel, is proof that Antarctica's underworld is not static. As radar specialist Dr. Robin Bell has said, "We're listening to the continent's pulse with every pass." The ice, once thought silent, now reveals a restless network of movement, its arteries mapped not by sight, but by the echoes and light that slip beneath the white. The challenge now is to reach these hidden rivers directly, to sample what flows in the dark, and to understand the forces shaping this secret world. A drill rig stands alone on the polar plateau, surrounded by nothing but wind and endless white. The goal: to reach water sealed away for millions of years, buried beneath kilometers of solid ice. In the case of Lake Vostok, Russian engineers faced nearly 4,000 meters of ancient ice, a barrier thicker than the tallest peaks of the Alps. Their solution was as audacious as it was controversial. Mechanical drilling lubricated with tens of thousands of liters of aviation-grade kerosene and freon. The world watched as the borehole descended, year after year, deeper into the unknown. In February 2012, after decades of effort and bitter debate at Antarctic treaty meetings, their drill finally broke through. For the first time, water from Lake Vostok surged up the shaft, carrying with it secrets locked away since before the first humans walked the Earth. But the triumph was shadowed by worry. Scientists and environmental groups warned that kerosene and surface microbes might have slipped into the lake, forever altering its chemistry and biology. The question lingered: had humanity touched a pristine world or contaminated it in the moment of discovery? On the opposite side of the continent, a new generation of explorers assembled at the edge of the Whillans ice stream. Their method was different: sterile hot water drilling designed to melt a clean path through 800 meters of ice. The Wizard team filtered, ultraviolet sterilized, and pasteurized every drop, building a borehole with water as pure as any surgical field. In January 2013, after days of round-the-clock work, disaster struck. The filtration system clogged, and the clock was ticking. Midwinter cold threatened to freeze the borehole shut before the team could reach the lake. Lead engineer Jim Bowie and project manager Allison Murray worked through the night, improvising a bypass with spare parts and ingenuity. The system roared back to life with minutes to spare. When the drill finally reached the hidden lake, the team celebrated, not just for the technical victory, but for protecting the untouched ecosystem below. Samples of water and mud rose from the darkness. In the lab, DNA sequencing revealed a thriving community of microbes. Hundreds of species, some never seen before, living in total isolation from sunlight and air. For the field lead and her team, the moment was electric. The risks had been immense. A single mistake could have meant lost data, wasted years, or the accidental introduction of foreign life. Instead, they held proof that life endures in the most forbidding corners of our planet. The first contact with Antarctica's black waters was not just a story of technology and perseverance, but a test of scientific responsibility. A reminder that the line between discovery and destruction is razor-thin beneath the white silence. Each winter, teams of researchers return from the field with something more precious than gold: cylinders of ancient ice lifted from depths where sunlight has never reached. These ice cores are not just frozen water. They are time capsules, each layer pressed into place by the slow weight of snow, recording the world as it was year after year, century after century. Inside these cores, the past is preserved with a clarity found nowhere else on Earth. Tiny bubbles of air, trapped as snow turned to ice, hold the atmosphere of vanished ages. Carbon dioxide and methane, locked away in these bubbles, reveal the rise and fall of greenhouse gases across ice ages and warm spells. When paleoclimate analysts slice into a core, they are reading the breath of ancient forests, the exhalations of extinct animals, and the long, slow drift of planetary cycles. The ice remembers more than just the air. Flecks of volcanic ash mark distant eruptions, Krakatoa, Tambora, and events older than recorded history. Each layer a silent witness to catastrophe. Pollen grains drifted from far-off continents, cosmic dust from meteor showers, even the faint chemical traces of wildfires and ocean blooms, all pressed into the archive. The ratio of oxygen and hydrogen isotopes in the ice tells the story of shifting temperatures, mapping cold and warmth in delicate bands that stretch back nearly 1 million years. Eric Steig, a paleoclimate scientist, describes the work as reading a ledger written in ice. Every centimeter is a chapter. Some years thick with snowfall, others thin and brittle from drought or volcanic winter. The deeper the core, the further back the record stretches, until the bottom layers recall a world unrecognizable to ours. A planet where ice sheets waxed and waned, and the shape of continents themselves was different. But this archive is not perfect. As the climate warms and the surface melts, some chapters are lost forever, erased before they can be read. The ice remembers, but it can also forget. In its silent layers, the memory of Earth persists, fragile yet enduring, waiting for those who know how to listen. Radar pulses sweep across the frozen horizon, searching for echoes that hint at emptiness where solid ice was assumed. In 2019, data from Operation Icebridge revealed a void beneath Thwaites Glacier, 40 cubic kilometers of missing ice, a space nearly half the size of Manhattan. The discovery stunned even the most seasoned scientists. Dr. Pietro Milio, part of the team analyzing the radar returns, described the cavity as a cathedral hollowed out by forces both ancient and ongoing. The pilots flying the Icebridge missions recall the tension of these survey flights. With nothing but white below and radio static in their headsets, they navigated turbulent skies over West Antarctica, tracing grid lines above a landscape they could only imagine. One pilot later said, "There is nowhere to land out here. You are alone, hunting for echoes." Each pass brought new data, lines of radio waves slipping through ice, bouncing off bedrock and returning with signatures of hidden space. No warning lights, no sudden alarms, just a pattern in the data where the ice should have been solid. These vast cavities do not form by chance. At the base of the ice, the planet's own heat seeps upward. Geothermal gradients here can reach 150 milliwatts per square meter, enough to keep water liquid even as the air above drops to -50. Tectonic forces, deep faults, and the friction of ice grinding over rock all feed this invisible fire. The heat carves out voids, melts channels, and powers the slow collapse of ice from within. The Thwaites cavity is not an isolated phenomenon. Airborne radar surveys have mapped similar cathedrals of emptiness beneath other glaciers, spaces that shift and grow as water flows, ice thins, and the ground below flexes. Each new void is a reminder that Antarctica is not a monolith, but a living system shaped by energy rising from the core of the Earth. Geophysicists studying these data speak of habitable niches, pockets where liquid water and mineral-rich sediments gather, shielded from the sun for millennia. In these dark sanctuaries, the ingredients for life persist, waiting for a spark. The story of Antarctica's hidden cathedrals is not just one of emptiness, but of potential, of energy, water, and the possibility that even here, in the world's deepest cold, life might find a way. Beneath the darkness under Antarctica's ice, life persists in ways the surface world never imagined. When researchers first drew water and sediment from Lake Whillans, they faced a question as old as exploration itself. What could survive in this lightless, frozen vault? The answer arrived under the microscope and in the sequencer's output. Hundreds of microbial species, each adapted to a world without sunlight, revealed themselves. Their DNA, decoded by 16S ribosomal RNA surveys, mapped a hidden tree of life. Bacteria and archaea, thriving where only chemical energy is available. These microbes do not photosynthesize. Instead, they harvest energy from iron, sulfur, and even hydrogen, stripped from ancient rock ground to powder by moving ice. Some break down ammonia, others oxidize methane or reduce sulfate, building entire food webs in perpetual night. Every drop of water from beneath the ice holds a living archive with metabolic pathways as varied as those found in the deep sea or in the world's oldest mines. Cell counts in Lake Whillans reach up to 1 million per milliliter, rivaling surface lakes in temperate climates. Many of these organisms have no close relatives anywhere else on Earth, an evolutionary experiment running for millennia in isolation. The diversity runs deeper still. Sediment cores extracted from the lakebed show layers of DNA, each a record of past microbial communities that flourished and faded as the environment above shifted. Some lineages have persisted through cycles of glacial advance and retreat, while others lie dormant, waiting for the return of liquid water. Activity measurements confirm that life here is not just surviving, but growing, slowly, steadily, powered by the chemistry of stone and water. Teams from NASA and the European Space Agency study these lakes as analogs for the oceans beneath Europa's ice or Enceladus's crust. The lesson is clear. Sunlight is not the only path to life. Where there is water, energy, and time, possibility endures even in the deepest cold and the longest dark. The hidden rivers and lakes of Antarctica remind us that life's story is not limited to what we see. It is written in every place the world keeps secret. Every year, Antarctica's ice surrenders a little more of itself to the ocean. The numbers are stark. West, Antarctica loses an average of 147 billion tons of ice annually, with Thwaites Glacier alone accounting for nearly 100 billion tons each year. These figures are not abstract. They are the slow unraveling of a planetary archive. As the ice thins and retreats, ancient air is released, dust and pollen scatter, and layers that once held the memory of vanished climates slip away into the sea. The process is not steady, but accelerating. Satellites track the shrinking edge of Thwaites, sometimes called the Doomsday Glacier, where a hidden cavity nearly half the size of Manhattan has grown in just a few years. If Thwaites were to collapse completely, global sea levels could eventually rise by more than 60 centimeters, enough to redraw coastlines and flood cities far from the southern cold. This is not a distant threat. The glacier's mass loss now accounts for 4% of annual global sea level rise, a figure that grows with each passing season. But the loss is not measured only in water. With every melt, the ice releases its stories: trapped air from ice ages, traces of ancient forests, the chemical signatures of volcanic winters, and warm spells. These are chapters of Earth's history, written in layers that cannot be replaced. When the ice vanishes, so does the record, a memory erased before it can be read. Antarctica's melting is a mirror, reflecting not just planetary change, but human time. The ice does not judge or warn, but it does remember. In its silent retreat, it offers both evidence and elegy, a reminder that what is lost is not only mass, but memory itself. The white silence grows thinner, and the world's oldest stories begin to slip beneath the waves. Antarctica's hidden rivers now shape sea levels and global futures, real time. As the West Antarctic ice sheet melts at unprecedented rates, ancient secrets and warnings rise with the water. What lies beneath is not just memory, it is tomorrow's reality. In listening to the ice, we confront our own reflection, and the world's most silent continent becomes impossible to ignore.